Let me hit record. Hello, happy Freedom Day to everybody in Sydney. People on the poll seem pretty excited. 21 people said hooray for Freedom Day. 6 people said, wait, what? If you're not in Sydney, let me fill you in. Today we've had some of the COVID restrictions relaxed so we can move around and do things, which is kind of nice. Um, yeah, I think Sydney siders are pretty positive about what's going on now. So I hope you're enjoying your Freedom Day, and wherever you are, you're having a good day. All right, Russell. Russell's got a question. I've got some questions here. Yeah, yeah, Lisa. The thing is, everybody gets a different question, right? So if you're doing the practice exam, your practice exam is not going to be the same as mine because there are an infinite number of different questions. But I've got a whole bunch of different styles here. Okay, so let's work through a few, and we can. I'm happy if you want to put stuff in the chat. We can talk about domain and range and stuff like that, Lisa. And if you can type question 13 into the chat, Russell, I mean that would be fine as well. So why don't I kick things off? It's kind of interesting. There are 55 people here for the revision class, and there were only 50 people in today's lecture. So people are going where the where the action is. All right. So let's get down to it. Yeah. Well, Lisa, why don't we start with yours, and then we can move on to other questions. Okay. How does that sound? Let me grab some paper. Oh, all right. So let's do Lisa's first, and then we can move on to some of the ones that I've done. All right. So I'll just share my document camera with you. All right. Here we go. Okay. So this is the Lisa question. Do 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 do. All right. So this is the Lisa question. All right. So the question is, and I'm just doing this off the chat. Let me know if I'm wrong here, Lisa. Okay. So that's the function that we are interested in. And the idea is to compute the domain and the range. Okay. So let's do the domain and let's do the range. Okay. So with the domain, we kind of just look for those values of x that break maths in some way, right? So dividing by 0 is one way of breaking it. Taking the square root of the negative number is also another way of breaking the function. So we want all x such that this thing is not 0 and the thing inside the square root is non-negative, right? So if you combine both of those things, if this is positive, it's not 0, so you can't divide by 0. And of course, you can always take a square root, right? So let's work with this. I can say factor that out. And do that. And sometimes people like to draw this, right? So this is going to be one of those functions that cuts at -5 and it cuts at 0. And you're going to get a parabola that kind of looks something like that. Yeah? Okay. So that's the graph of this. All right, so who can tell me where is this function positive? What are the x values? Who can tell me on the chat? What are the x values for where this thing is above 0? Who can tell me? There's 57 people here today. Right. Advaita, yes. So between here and here, that's where the curve is above the axis. Okay, so hence the domain of f is here. All right, so thank you. -5, right? Oh, hang on. Have I made a mistake with my picture there? Maybe, hang on. X equals, oh yeah, sorry, I've made a mistake with my picture. That's not good. Okay, let me, okay, 5 and 0. That's better. All right, so now it's going to be between there. Okay, so let me fix that up. Sorry, folks. I'm getting too hyped up with Freedom Day. All right. Thank you. Thanks everyone on the chat. Okay, so that's going to be your domain, right? So for those x values between 0 and 5, it's okay to plug them into here. All right. So what about the range? This goes back to your original question, Lisa. So how can we compute the range? Anybody know? Anybody want to suggest something to Lisa in the chat? Let's have a look at the output. It's definitely positive, right? So the output is, it can't be negative because you've got a positive there and a positive there. Who can help Lisa out with the talking about the chat? Any ideas in the chat with the range? Any ideas? Yeah. Yeah, you can find the maximum there. So the maximum there is going to be exactly halfway between 5 and 0. So you know that when that has a maximum, this whole thing is going to have a minimum, right? So Eloisa, you're absolutely correct. And Advaita, you're correct too. So you just look, because this is a parabola, you just look for halfway between the intercepts, right? So it's 2.5. All right. So to find the minimum value of this function, you would just sort of work out what 2.5 is for this thing, and then go up. So if we have a look at a quick picture, let me just put that in there. Okay. So there's GeoGebra. You can see there's 2.5, right? That's where the minimum of this function is. Okay. Okay. So to find the, so it'll go off to positive infinity, and it'll be the range of that, right? So the range of f, it's going to be f of 2.5 off to infinity. Okay, so all you need to do then, oh, sorry, let me share my screen. All you need to do is work out what this is. Okay. It's going to be 0.4. Okay. Now remember, in this test, you'll be able to, use things like GeoGebra and stuff like that. You've got access to graphics calculators, all that sort of stuff. So you should be able to use this you can just do it by hand if you want to, but you can actually save a lot of time if you use something like a graphics calculator. Yeah, that's okay, Lisa. Sometimes it's good to draw a picture. Okay, sometimes it's good to draw a picture, even if that's with GeoGebra or graphing calculator. or something like that. So there's your range. Obviously, I wasn't thinking there, but that's the correct graph. And then that's what it is. All right, good job, good job. All right, let me go to the a vector is parallel to a plane. Okay, so let me think about that. So do you, Carl, do you have a particular question for that? Or, do you want to state the question in the chat? Because that would be helpful, because I mean, all you really need to do, right, if you've got a plane, right, and you've got a vector, okay, and you want to show that that's parallel to that, all you need to do, let's say they're your two vectors that span your plane. And this is, I don't know, the vector Q or something, right? Show that Q is in the span of V1 and V2. That's it, okay? That's sort of the high level stuff, right? So that's really what you're doing. Okay, so you address this problem in Mobius. Is this for the practice test, Carl, or is this for the questions this week? I mean, that's what you're trying to do, right? So you're trying to show, yeah. So look, this is a revision class, Carl, yeah, but this isn't a homework class, Carl. The only reason I'm doing this is for everyone else, the 63 people who are here who want some help with Mobius. Okay, so yeah, I'm not going to do the homework in today's classes. I hope that's okay, because as you know, this is a revision class for Mobius, right? Great. Okay, so let's have a look at some of the questions. Might just zoom in a bit there. Yep. Okay. All right. All right, so I'm going to start with the harder problems first, and then I'm going to sort of work backwards. Okay, so this is a limit type question. You've got a function, and they tell you that the limit as x approaches infinity is 2. Yeah, yes, that's right, Hulan. This is the formal definition of a limit. I know it's probably a bit hard to see on my screen, but let me see if I can actually get in there a bit better. Okay. All right. So find the smallest value for m greater than 8, such that if x is bigger than m, this distance is small, and then they want you to enter it. Okay, so you're on the right track. So let's consider this distance, right? So we want to work with this and then solve it in some sense, right? So we're solving an inequality. So okay, so what we would like to do is simplify this expression, and this is very common in these kinds of problems, right? So let's put it all over one denominator. So that'll be 16. Okay, and you can see that the algebra is going to be pretty nice. That disappears, and you've got 16 on the top and x minus 8 on the bottom. Okay, so what we're going to do to get rid of the absolute value signs, that's our next step. 16 is positive, and x minus 8 will be positive because x is bigger than whatever m we're going to come up with, and m is going to be bigger than 8. Okay. All right, so the justification there, going from there to there, firstly, the top's positive, so you can get rid of the top part. The bottom's going to be positive because we're told that x is going to be bigger than m and m is bigger than 8, so x is definitely going to be bigger than 8. All right. So now we can introduce this epsilon, and we want to solve for x. Okay. So we've still got this condition, but let's work this out now. Okay. So it's going to be, bring that up there. And now let's make x the subject, bring the other 8 to the other side. So let's go x greater than 16 on epsilon plus 8. Okay, so that's obviously true, because if this is true, that's definitely true because this is bigger than that, right? You've got 8 plus something. So what we would do, we would just input that into our box, and they tell you the syntax here, which is nice. Okay, so you would so who can tell me in the chat what would you actually type into the box for this? Who can actually tell me what the syntax would be? What would you actually enter into the box? Who can tell me in the chat? Yep, just the whole expression. What would you actually type in? Yeah, that's right. Good job, people. Although, what's your syntax there, Lisa? Yeah, exactly. Okay. Now remember, you can look at, if you press this button, it'll tell you what the mathematics looks like. Okay. Sorry, Pratikansh. Sorry, mate. It's a live stream. Okay. Haha. If only. All right. So that's what you would put. All right. Let's look at another one. Okay. In this question, it is the maximum minimum. That's my best German accent. The maximum minimum theorem. Okay. Select each line below for which the maximum minimum theorem guarantees the function attains its max and its min values on the domain. All right. So two things to worry about. The interval and the f, right? So we want the interval to be closed and bounded, something like this. And want the f to be continuous. They're the two things that the maximum minimum theorem depends on, right? If any of these are broken, then you can't apply the theorem. Okay, so who can tell me? Let's leave this one. Is the second one? Can I use the max min theorem there? No. Why not? Because it's not a closed interval. What about the third one? Can I use the maximum minimum theorem on the third one? No. Why not, Lisa? Why can't I apply the maximum minimum theorem here? Right, it's not continuous on the interval, right? So that one's broken. What about the fourth one? Can I apply the max min theorem there? I can. That's a closed interval and that function's continuous. What about the second last one? Can I do the max min theorem there? Who can tell me? Steve. No, why not? The interval's not a closed interval. Ba, ba, ba. Okay. So what about the first and the last? Okay. The first one looks crazy, but on this interval, it's a closed interval, right? And this is my function. Okay, so on this interval, that's part of this. It's a closed interval and this is continuous. So I can definitely do the max min theorem there. Yep. What about the last one, people? Can I apply the max min theorem on the last one? Okay, closed interval, and that's continuous. That's continuous everywhere, right? So it'd be that one, and that one. Yeah, you're all correct. So yeah, you just tick them. It says select each line, which is fine. Okay. All right, here are. Okay, so two things with the maximum minimum theorem. The interval has to have the right structure and F has to satisfy the continuity on the interval. Okay. All right. We're working backwards, people. Russell, what do you mean? Does it have to be continuous at 0? It has to be continuous on the whole interval, right? So on AB. So for every point in AB, F has to be continuous at that point. Yeah. All right. Another split function. Here's our g of x. It says it has a discontinuity at x equals -7. What happens to the left hand and the right hand limits at this point? Okay, so I mean, one way of doing this is just to see if you can factorize, right? So it's going to be something like x minus 7, x plus 5 over x plus 7. So you can't actually factorize here, right? You can't actually factorize. So Monique, there you go. That's from the last one. Okay. So there's no way that you can factorize these things off and then try to simplify it, because it just doesn't work. Yeah. So what does this look like in as a picture? Now you could do this using limits, of course, but let's have a look and see what it looks like. I'm just going to type it into GeoGebra now. Okay. So here it is. So I'm just going to share it with you now. Okay, so here's the graph of the function according to GeoGebra. Now I haven't included the definition of x equals -7. Okay, so at x equals -7, the actual value of the function is down here somewhere. Okay, so it's discontinuous. What kind of discontinuity? Are the left-hand limits and the right-hand limits equal as we approach 7? So -7? Who can tell me on the chat? So you've got this function, and g, we've defined g of -7 not to be this, but it's 0, right? Oh, maybe I should zoom out a bit. Okay, so it's sort of 0 down here. So what's the left-hand limit and the right-hand limit according to that picture? Who can tell me on the chat? As we approach -7, who can tell me? Who can tell me? Yeah, you can see as we come in, that's right, I-Chan, Russell, good. So as we come in from the right, the curve pops off to positive infinity. As we come in from the left, it pops off to negative infinity. So the limits are definitely not equal, right? And they are positive infinity and negative infinity, right? So if I go back here, let me just go back to the question. Okay, so I'm not sure what you actually get here, but the limit as x approaches -7 from the right is positive infinity. and the limit as x approaches -7 from the left is -infinity. So these are definitely infinite limits and they're not equal. Okay, and there'll be probably a little drop down thing there to say, hey, you know, the limits are infinite and not equal or something like that. And now the question then goes on, if the function g can be turned into a continuous function, enter that value below. If it can't, enter none. Okay, so let's go back to the question or the picture. Is there a way of making this function continuous at x equals -7? Is there any way? No, it's impossible, right? It's absolutely impossible. So because you can't just plug one point and fill this gap. Okay, so for that one, I'd be looking to enter, you know, none or something like that. So down here you would have something like none. Oh. Okay. So yeah, you're right, Lisa and Steve and Hulan. So it's just not possible. Okay, let's keep on moving. Russell, I think we're getting towards your question number 13 now. Let me know if you see it. Okay. Oh, this one. Oh, great. Okay, well, let's talk about this then. Okay. So you've got another split function. And you probably have two discontinuities there where it doesn't make sense. X equals 1, x equals 5. At the discontinuity at 1, the left hand and the right hand limits are, okay. So Steve, what are the options? Russell, what are the options here? Let me just put this in and I will do a picture. Okay, 1 and 5. Oh yeah, okay, all right. So let me go over to my picture. So you can see there's a problem at +1 and +5. Okay, so as we approach +1, which is here, what's the left hand and the right hand limit doing? Who can tell me in the chat? Russell, why don't you tell me? What are the limits as we approach 1 from the left and 1 from the right? Yeah, they're both going to -infinity. Okay, so that's the that would be the left hand limit goes to -infinity, the right hand limit goes to -infinity, right? And so the next question is, sure, there's a discontinuity down here. Can I plug the hole? Can I plug the hole to make this a continuous function at x equals 1? Is it possible? Well, can I make a function of make a value at x equals 1 to make this function continuous at x equals 1? Is it possible to do? That's the question. Okay, that's the question. No, it's not. It's not possible. Okay, it's not possible. So let's write that down. Okay, so here we have the limit as x approaches 1 from the negative side. That's -infinity. And that's the same as 1 from the positive side or the right-hand side. Okay, so when you click on that, it should reveal a list and you can choose the appropriate one. So down here, again, it's not possible to to plug the gap. So then, I mean, a good question here is, when is it possible to plug the gap, right? So let me just quickly show you something where, like, you might get an example where it is possible to plug the gap. Okay, so you might have a function that looks like this. Okay, and there's a discontinuity here, let's say at 2 or something. What you would do, you would move this dot up to here and plug the gap so everything's nice and continuous. Okay, but it's not possible with a function like this. It's because there's too much space to fill. Here you've only got to fill one little dot point. Where you have the other functions, it's just not possible to do so. Okay. All right. What about another one? Well, I think I've done that one. Or maybe we should do that just for completeness, because this is similar to this one now. Okay, and I'll see if I can do this one without GeoGebra, because I know, I mean, sometimes they want you to do this just by hand, right? But sometimes it's much easier if you have GeoGebra. So why don't we see if we can do this? I have a feeling this is going to work out nicely. So if we factorize the top, I'll get something like that. Okay. And so what I can do, because x is not equal to 5 here, I can simplify. Oh yeah, plus. I can simplify. Thanks, Lisa. Okay, so I'm just ended up with x plus 3. So now I've got a situation where I've got x equals 5, sorry. I've got like 5 there. I've got maybe 3 there. And that's my top part of the function. And it's 0 down here. Okay, so at this discontinuity, the left-hand limits and the right-hand limits, well, what's going on? Who can tell me what, if that's f, what is the left-hand limit as we approach 5? Who can tell me? It's going to be 8, right? So, because we can just take 5 and put it in there, 5 plus 3 equals 8. And what about the right-hand limit? It's going to be the same. Okay. Good job, everyone. Loving those chat comments. Okay. So now, if the function f can be turned into a continuous function by sort of shifting this value, what should the value be? Yeah, people are saying 8. Exactly. Okay, so 8. Because then you move that up there and you've plugged the hole, and it's a nice continuous function then. Okay. So that's one of those examples where you could get the factorization, you could just move the point around. This is called a removable discontinuity. Okay. It's removable discontinuity. Means you can just plug the hole with one point. And the other ones, well, you can't remove them. Okay, it's not possible, no matter how you redefine the value at that point. Okay, so that's an example of one where you can actually do it. Cool. All right, what's next? Okay, Let me just move these around a bit. All right, domain and range. Now, we already talked a little bit with Lisa about this, but I think this is actually a pretty easy question. You've got a function here. I mean, you can draw this if you want to in on your calculators or whatever. Probably the most important thing here is when you input it, they're asking you not to use maple syntax. They want you to use round and square brackets, or R for the whole real line, infinity, negative infinity for these things. Okay, do not use decimals. The preview will not work for this question. Okay, so who can tell me what's the domain of this function? Who can tell me on the chat? Who can tell me? On Freedom Day. Yeah. Ah, Hulan, yes, you're close. You're very close. Yes, you want the square bracket. Okay, Lisa, yep, true. So you're both correct. So here's GeoGebra. You can see the domain starts at -2 and goes off to positive infinity, and the range, well, it just keeps on increasing, right? So let's write that down. So for this one, you want, of course, x plus 2 to be greater than or equal to 2, because you can't take the square root of a negative number. Okay. So that's your domain. And the range, well, the square root is always greater than or equal to 0. And when x equals -2, this thing is 0. So okay. So the domain would be something like this. Yep. And the range would be something like that. And so you just need to put it into the right syntax for these questions. Okay. So that's a pretty easy question. If you get a question like that, you should be able to do it very, very quickly, right? Okay. All right. Well, let's keep on going. Yeah. Now, these inequality ones, you might remember them from high school. If not, that's okay. You're asked to solve for all x this inequality. And of course, we see that obviously x, whatever we find, x can't be -7 because the left-hand side isn't defined. To enter your answer, don't use maple syntax. Use the standard interval notation. Again, with the round and the square brackets, the preview won't work for this question. Okay, so one way to do this, I mean, you could just load up maple, of course, and it will just solve this for you. But one way to do it just by hand, and I think that's the way they want you to do it, is to multiply both sides by something positive or something negative, and to make the left-hand side simpler. Okay, so if you want to do this by hand, what you can do is multiply both sides by a positive thing. Now, why do we choose a positive thing? Well, the reason is if we multiply both sides, you keep the same inequality. You don't have to worry about flipping it or doing anything crazy. Okay, and of course, you can simplify. Okay, so I'm going to move this over there, and we'll get something like this. So that comes over here. Now, it's very tempting to expand the brackets, but there's a common factor. So don't expand the brackets, okay? So what are we going to get? We're going to get something like that, okay? In fact, what I might do, I might just multiply by the 5 there. Okay, so instead of having it down there, I'll move it up there. And so what that means is you actually get a nicer bracket. Okay, you can do it your own way though. It's up to you. Okay, so let's simplify what's in here and then okay, it's a parabola. It's going to cut the x-axis at -7 and -12. So let's say that's -12. That's -7. You're going to get a parabola looking like that. Okay. So where is this negative? Well, it's negative down here. It's below the x-axis there. So from the graph, we see that x is less than -7 and greater than -12. Okay. So if you're putting this syntax in here, it would be something like -12, -7. Okay, that doesn't conflict with this because this is an open bracket, right? Okay, so that's a little bit longer. I mean, if you just crank open Maple, Maple will solve this for you in like half a second. But I don't think that's the way they want you to do it. When lab test 2 comes along, you'll definitely be expected to do Maple, right? So that's really. I hope you are all experimenting with Maple a little bit. Okay. All right, so that's that one. The rest, oh yeah, okay, let's do this one. Yeah, this is a good one. Let's have a look at this one. All right, who can help me out in the chat for this one? Select all the true statements. Select all the true statements. Okay, maybe you guys can help me out as we go along. We've got two functions here, cosine x and cosine x over x for large values of x, large and positive, right? So, Steve, you think this is false? Okay, it's definitely false. Why? Because the limit, I mean, cosine x just goes up and down and up and down. It doesn't actually reach a limit. What about the second one? Does this limit exist? The second is true. True dat. Okay, so this limit does exist because, I think what happens is it kind of just goes like that and it goes towards 0. Whereas this one, cosine function, just keeps on going, right? Okay. What about the third one? Is this true? Yeah, it's false. I mean, if you know the first one's false, then the third one's definitely false. What about the fourth one? True or false, people? Let me know on this Freedom Day. It is true. Why? Because the x dominates cosine x and it drags it down towards 0. Okay, number 5, this limit is undefined. Is it true or is it false? True dat, that is true. okay, because it doesn't exist, right? This limit is undefined. Is dat true or dat false? Is this undefined? Definitely false, right? Because we know it's 0 from this one. Okay, last one. This limit is undefined. True or false, people? Jovanka says true. True dat. Abdul Rahman says true dat. What do we think? Okay. Let's have a look. It is true, but let's actually see what happens in GeoGebra. So you can see around 0, well, we're not interested in that. We're interested in what happens as x gets large. And you can see it just keeps oscillating between +1 and -1, right? And the reason is this, as x gets large and positive, this thing doesn't contribute much to this. Okay, so this cosine x dominates. Okay, so it's definitely true. Okay. Okay. Oh, hang on. What did I just write there? That's true. Okay. All right. So, oh no, that's false. What am I writing? You know, some people, they write like this, just to sort of, they're not sure if it's a true or a false. Don't do that. All right. That is just about all the questions I wanted to talk about, people. So, let me turn everyone's, yeah, everyone can share their video or share their audio. Does anybody have any particular questions for me, like about the test, or you know, like some people are still asking on the Moodle forum, what time does the test start? What time does the test finish? Like, can I start the test at 4:55 p.m.? Well, you can, but you're not going to finish it, right, by 5 p.m. So the most important thing is to finish the test before the time. Don't start it at 4:55 when the deadline is 5 p.m. Okay? Abdul Rahman, watch me. Yeah. All right. So, Steve, 12 to 14, what do you mean? Oh, the dates? Yes. So I think it opens tomorrow. Yeah, so you're right. Yes, accept that challenge, Hulan. All right, Russell, piecewise functions. Sorry for the dumb question, but the piecewise functions we did are continuous, equal. How do we, using limits, Russell. So you just look at the left-hand limit and the right-hand limit and see if they're equal, okay? That's pretty much how you do it, okay? Yeah, so wherever the definition changes, you just look at the left-hand limit, the right-hand limit, see if they're equal and equal to the value of the function at the point, right? So you don't want any jumps or breaks in the curve. I think that's really important. Yeah, Pratikansh, you can start at any time during the 2-day period, right? So yeah, so maybe I should just get the thing up. Let me just have a look. I can just share this with you now. So here it is, people. So it will run from 9 a.m. on Tuesday until 5 p.m. on Thursday. You should have been enrolled in the class by the time you read this message, okay? So preparing for the test. the most important information or for practicing the test, do the practice test. There's no surprises, right? There's no surprises. Ramona, I don't know. I mean, I don't think you can take I don't think you can take a practice test while you're doing the real test. I don't think that's possible, right? Yeah, I don't know. I don't know, Ramona. That is a good question. Maybe you could ask that in the Moodle forum. Okay, Madhav, we can't start because the declaration is set for the 14th. I don't know about that. Maybe you could ask that question in the Moodle forum. So Russell, if it's a straight line, you just put the value of the limit that you're approaching into the function. Yeah. So yeah. So that's it. Just try the practice test for to know what topic's on. Okay. Now you can't apply for special consideration unless you fall ill during the test. Okay, so yeah. So I mean, it's pretty. You definitely want to try it because it's pretty easy marks, right? Most people get 100% for this question. Oh, Madhav, okay. Somebody's already asked it in the Moodle forum, but no one's replied yet. Is that right? I'm sure someone will reply. They're pretty quick with that sort of stuff. So Russell, when you're taking the limits, you want the left-hand limit, the right-hand limit, and the value of the function at the point that you're approaching. They're the three things. They need to be equal for it to be continuous. Okay. All right, Madhav, I'm sure that someone will reply to you in the thing. I'll see if I can find out. But just enjoy Freedom Day, people, and good luck tomorrow. You can do it, right? Like if you're starting the test tomorrow, good luck, or whenever you start it, try to get 100%. I have faith in you, people. I have faith. So just enjoy the day, and I will see you on Thursday. By that time, pretty much everybody will have finished the test. And yeah, Pratikash, you can feel free to blast that integration song loud as. We'll see you later in the week. Get 100%. The Minecraft Spider says, yes, 100%, everyone. And good luck. All right, everyone. See you.